In our last video, we have learned how to find a particular integral when right hand side is e power of ax plus by or sin ax plus by or cos ax plus by. Now, in this video, we are going to learn how to find a particular integral when right hand side is a function of phi of a plus ax plus by, that is x plus y. So, coming to an example, here the given partial differential equation is this one. Here also this is a homogeneous partial differential equation. That means here the order is same, dou square, dou square, dou square is there. So this is a homogeneous differential equation. So the auxiliary equation for this partial differential equation is this is m square plus m into 1 6 into 1 square. That is, in place of d we write m, in place of d dash we write 1. After writing in place of d and d dash in this equation and it equating to 0, this becomes auxiliary equation. So solving this equation, we get roots m is equal to minus 3 comma 2. Therefore, the complementary function is f1 of y minus 3x plus f2 of y plus 2x. That is, these two roots are real and different. Therefore, we write in this form f1 of y minus 3x plus f2 of y plus 2x. Coming to particular integral, here we are writing in place of d 1. That means this is of the form ax plus by. So compare x plus y with ax plus by. We get a is equal to 1 and b is equal to 1. That's why in denominator I am writing in place of d 1, in place of d dash 1. So here I am assuming x plus y as some u, Therefore, in denominator, the function is of second degree. Therefore, we write double integral here. Double integral u du. Therefore, here denominator is not equal to 0. Therefore, there is no problem at all. So after integrating u 2 times, we get u cube by 3. That means u cube by 6. Therefore, after simplifying this one, minus 1 by 24 into u cube. After integrating, we are replacing in place of u x plus y. Therefore, the PA is minus 1 by 24 into x plus y whole cube. The complete solution is CF plus PA. So the CF is this one and PA is this one. Combining these two gives complete solution. Z is equal to f1 of y minus 3x plus f2 of y plus 2x minus 1 by 24 into x plus y whole cube. Next, we take another example. D square plus 2d d dash minus 8d dash square into z is equal to 2x root of 2x plus 3y. Here also we find auxiliary equation by replacing d is equal to m and d dash is equal to 1 in this equation. In this one, we get and equating to 0, we get auxiliary equation like this: m square plus 2m minus 8 is equal to 0. Therefore, the roots are minus 4 comma 2. Therefore, the roots are minus 4 comma 2. Complementary function is f1 of y minus 4x plus f2 of y plus 2x. So for finding PAE, 1 by f of d comma d dash, this is general formula. I am writing instead of square root, I am writing power of 1 by 2. Here also the function is of second degree. Therefore, here a is equal to 2, b is equal to 3, b is equal to 3. Therefore, in denominator, in place of d, we are writing 2 and d dash 3. Therefore, this becomes minus 56. Minus 56. So here also this is second degree. So we are integrating u two times. After integrating u two times, we get this one. U power of 5 by 2 by 3 by 2 into 5 by 2. After all simplifications, the final answer is minus 1 by 210 into u power of 5 by 2. In place of, again in place of u, we are replacing u is equal to 2x plus 3y. So this is the PI. The complete solution is complementary function plus particular integral. So combining this CF and this PI gives the complete solution. Gives the complete solution. Next, take another example. D cube minus 3dd square d dash minus 4d d dash square minus 12d dash cube into z is equal to sine of I plus 2x. So here also, first we assume auxiliary equation. We write auxiliary equation, this one. The roots are 2, minus 2 and 3. So therefore the complementary function is f1 of y plus 2x plus f2 of y minus 2x plus f3 of y plus 3x. This is the complementary function, this one. And coming to particular integral, 1 by this is f of d into sine of y plus 2x. This is of cubic equation of third degree. So we are integrating 3 times here. We are integrating sine u du du du. That means here in place of a, this is of the form sine, in place of here u is equal to y plus 2x. That means a is equal to 2 here. I am writing here a is equal to 2, b is equal to 1. Therefore, u is equal to y plus 2x means 2x plus y, a is equal to b is equal to 1. That means in this function, we write d is equal to 2, d is equal to 2 and d dash is equal to 1. That means in place of d we write a, in place of d dash we write b. Therefore, after writing this, we get this one, we got this one. So here this became 0, that is failure case. So as already we know that in case of failure, that means in denominator becomes 0, we write one x here, x into, we differentiate this function with respect to d. That means we differentiate partially dou by dou d of. So if you differentiate this function partially, this becomes 3d square minus 6d d dash. That means 3 into d square means 2d. 4d d dash square means 4 minus 4 into d dash square. This term becomes 0 because there is no d here. So this becomes 0. And again we substitute in place of d. In place of d, 2 d dash is equal to 1. Substitute here. Therefore, this is equal to plus 24 minus 24 gets cancelled and only minus 4 is remaining. Therefore, this is minus x by 4. If we integrate sine u 2 times, this becomes minus sine u. Therefore, the PI is x by 4 sine u. X by 4 sine u. This is our PI. So, combining these two, that means the complete solution is CF plus PI. This is CF and this PI. Combining these two gives the complete solution. That is Z is equal to f1 of y plus 2x plus f2 of y minus 2x plus f3 of y plus 3x plus x by 4 sine of y plus 2x. I am replacing here in place of u, we are replacing y plus 2x. Next, coming to another example. Here, on right hand side, we have log of 16 into log of x plus 2y. So, this is the PDE. This is the PDE. That means here also, first we write auxiliary equation. For that, we got roots m is equal to 1 by 2, 1 by 2. Therefore, the complementary function is c1 of y plus 1 by 2 of x plus x into f2 of y plus 1 by 2 of x. Coming to the particular integral, 1 by f of d into on right hand side given function 16 into log of x plus 2y. That means we are assuming x plus 2y as u. Therefore, 16 I am constant, I am writing here 16. No need of constant here. Here integral, double integral log u d, because this is second degree equation. We are differentiating two times. So here in place of d, x plus 2y means, or u is equal to x plus 2y means, x plus 2y means here x quotient is 1, that is a is equal to 1, and y quotient is 2, that is b is equal to 2. So in place of d, I write 1. In place of d dash, 2. Therefore, after writing d is equal to 1, d dash is equal to 2, this became 0. That means failure case. So again, in failure case, we write x here, 1x here, and differentiate this function partially with respect to t. After differentiating this, after differentiating partially with respect to d, this becomes 4 into 2d minus 4d dash plus 0. And again, we replace in place of d 1, d dash 2, we get again this becomes 0. This becomes 0. That is again failure case. Again, we are writing 1x here. So therefore, this becomes 16x square. Again, differentiate this one. Differentiate this partially with respect to d. This becomes 8 into 1 minus 0. Therefore, after simplification, we get 2x square into log u. This is pi. 2x square into log of x plus 2y. Therefore, for complete solution, we combine complete complementary function and particular integral. Therefore, this is CF in this particular problem. This is CF and this is PI. CF and PI. Combining these two, 1 and 2, gives the complete solution. So this is the procedure for finding when right hand side is of the form ax plus by. Next, coming to another method, that is case 4. When right hand side is of the form x power of m into y power of m, x power of m into y power of n. So first we take, for particular integral we write this of the form, and here if you observe, if m is greater than n, we change f of d comma d dash the function of in powers of d dash by d. Suppose if m is less than n, f of d comma d dash is changed into the form d by d dash. So consider an example. Same here also, for finding CF. For finding CF, we take m is equal to 1 and d is equal to m and d dash is equal to 1. Therefore, this becomes m square plus 1 is equal to 0. The roots are m square is equal to plus or minus I. That means one root is I, and another root is minus I. Therefore, CF is f1 of y plus ix plus f2 of y minus ix. So, for finding particular integral 1 by f of d into RHS, that means we are taking d square as common here, d square as common. Therefore, this becomes 1 plus d dash square by d square. This becomes 1 plus x whole inverse. So 1 plus x whole inverse can be written as 1 minus x in ascending powers of x, 1 minus x plus x square, like that. Therefore, after writing this one, 1 by d square, into 1 minus d dash square by d square means after simplification, this is the simplification, x square y square integral x square y square dx. That means 1 by d square means here 1 by d square means 1 by d square means we have to integrate with respect to x. Integrate with respect to x because it is d means dou by dou x, dou by dou x. 1 by d means this is the integration with respect to x. That's why I am writing here x square dx dx, not dy dy, only x square dx dx. Here also 1 by d power of 4 means we have to integrate 4 times. After simplification, this is the particular integral PA. So for complete solution, we write z is equal to CF plus PA. This is CF, this is PA. CF plus PA. So the complete solution is this one. Z is equal to F1 of F1 of y plus Ix plus F2 of y minus Ix, like this. Again, consider an example. So this is another example. Here also, first we write auxiliary equation. Auxiliary equation. So for that, we got roots 1 omega omega square, cube roots of unity. Therefore, the complementary function is f1 of y plus x plus f2 of y plus omega x plus f3 of y plus omega square x. This is the complementary function, and PA is given by 1 by f of d into, here also we are taking d cube as common. So 1 minus, because these two powers are equal, so we are taking d cube as common. So 1 by 1 minus d dash cube by d cube into x cube y cube. So we are expanding this one, 1 minus d dash cube by d cube whole inverse in ascending powers of x. After expanding, we are multiplying with x cube y cube. This becomes x cube y cube plus d dash cube by d cube. So here d dash cube means we have to differentiate with respect to 2. We have to differentiate partially with respect to y. That means d dash is equal to dou by dou y, dou by dou y. So for that only d dash cube means dou cube by dou y cube. That means we have to differentiate partially with respect to y 3 times. So that's why if you differentiate y cube 3 times, that becomes only, that becomes 6. Sorry, that becomes 6. Therefore x cube into 6. Here 1 by d cube means we have to differentiate x, we have to differentiate with respect to x. So we have to integrate with respect to x 3 times. 3 times. Therefore, if we integrate x cube 3 times, we get this one, x power of 6 by 6 into 5 into 4. Here also we have to integrate x cube 6 times. That means therefore this becomes x power of 9 by 9 into 8 into 7 into 6 into 5 into 4. So after all simplifying this, this is the PI. This is the PI. Therefore, for complete solution, we write z as complementary function plus particular integral. Therefore, z is equal to this one. This is the complete solution. So this is the procedure for solving when right hand side is of the form x power of m into y power of n. Next, coming to the general method. So this is the general method. That means whenever right hand side is any function, either it may be e power of ax plus y, sin ax plus y, whatever it may be, this is the general method. So in this general method, First, for finding PI, first we factorize the f of d comma d dash. First we factorize this one in this form. So in this, first consider a factor d minus m1 d dash and this function. So in this factor, in this factor or in this function, replace in place of replace y by c minus mx. Replace y by, instead of y we write c minus mx, because we are changing this integral into only single variable, that means c minus mx, not two variables. That is the technique here, trick here. So c is replaced by y plus mx, and after integration we replace c by y plus mx. So this is the procedure. So first consider a problem. Here also first way example, d square minus dd dash minus 2d dash square into z is equal to x minus 1 e power of x, y minus 1 e power of x. Here also same procedure for finding CF. This is the CF. For finding PI, I am writing here. So first we factorize. First we factorize this denominator. So this is these are the factors, d plus d dash into d minus 2d dash. So after factorizing 1 by d plus d dash into considering, in place of y we are replacing c minus 2x. This is the, because the two roots are, the roots are minus 1 comma 2. The roots are minus 1 comma 2. That's why I am considering one root 2. That means y minus 2x here. Y minus 2x. So y is equal to c minus 2x. So in place of y, we write c minus 2x and simplify this one. This is by usual integration methods. Usual integration methods. After all simplification, we got this one, this much. 1 by d plus d dash into y e power of x plus e power of x. Again, for 1 by d plus d dash, 1 plus d plus d dash, we are considering y as c plus x. So integral c plus x into e power of x plus e power of x dx. After simplification, we get pi as y e power of x. Therefore, for complete solution, z is equal to cf plus pi. So this is our complete solution. Cf z is equal to cf plus pi. So this is the procedure for general method of finding pi. Next, we consider another example. Here also, usual procedure, m is equal to minus 3 comma 2. M is equal to minus 3 comma 2. Therefore, the complementary function is f1 of y minus 3x plus f2 of y plus 2x. For finding pi, first I am considering this factor d plus 3d dash. In these two factors, first I am considering d plus 3d dash. That's why y becomes c plus 3x. That means in this function, replace y by c plus 3x and then integrate c plus 3x into cos x dx. So after all the integration, we get this much, this one. This one. And again, we are considering this factor. That means we have to consider y as c minus 2x. C minus 2x. Here also, in place of y, we have written c minus 2x. C minus 2x. After all integration, after all simplification. So this is the simplification. Here 2x cos x 2x cos x gets cancelled. 3 sin x minus 2 sin x becomes only 1 sin x. 3x 3 sin x minus 2 sin x becomes only sin x. Therefore, sin x minus y cos x. This is the PA. This is the PI. Therefore, for complete solution, Z is equal to CF plus PI. CF plus PI. So this is our complete solution. Z is equal to CF plus PA. That is F1 of y minus 3x plus F2 of y plus 2x plus sin x minus y cos x. This is the procedure for solving, for finding PI of any function. Of any function. So once again, I am reasoning. So if it is e power of ax plus by, if it is e power of ax plus by, write in place of d, a, d dash, b. That means in place of d, we replace a. In place of d dash, we replace b. That's all. If it becomes 0, if after writing d is equal to a and d dash is equal to b, if it becomes 0, we follow usual method. That means write x into 1 by dou d of that function. Dou by dou d of that f of d comma d dash. D comma d dash. Suppose if it is sin ax plus by, write d square as in place of d square. In place of d square, write minus a square. In place of d dash, write minus ab. In place of d dash square, minus b square. Minus b square. That is in sin, if it is in sin ax plus by. Suppose if it is x power of m y power x plus ay, only ax plus ay, ax plus by. Here also, first we consider x plus y as u, x plus y as u, and integrate 2 times because this is of second degree. We have to integrate 2 times. So this is all about homogeneous partial differential equation. That means whenever on left hand side we have same degree. That means dou square, dou square, dou square. If you observe the problems from first problem, I am coming. So first problem, dou cube, dou cube, dou cube is there. And coming to second problem, here also dou square, dou square, dou square is there. Same order. Here also dou square, dou square, dou square. So first we have to observe on left hand side whether it is of same order or not. If it is not same order, that is non-homogeneous. That is different case. Now we are learning about only homogeneous case. So here also in this example also, d square, like that, d dash. Here also dou square is there, dou square x by dou square z, like that. Here also dou cube, sorry, dou square, dou square. So here in this type also, here past the left hand side dou square, dou square, dou square is there. Here also d square, d square, d square and d dash square. Therefore, This is of second order. If you take this one also, d square, d square, d dash square, that means same order. So first, whenever we see linear partial differential equation with constant coefficients, first we have to categorize it as whether it is homogeneous or not. If it is homogeneous, we follow this procedure, these procedures. On right hand side, after that, right hand we have to observe on right hand side whether it is e power of ax by or sin ax plus by or only ax plus by form or x power of m y power of m or general method. So this is the procedure for solving for finding pi.